and welcome to an episode of Scope that asks you not just to get your head around it, but to get your teeth into it. Today we're talking about your food and where it comes from, so I hope you're hungry.
Most of us eat wheat all the time, from the bread we use for our toast and sandwiches to the cereal we munch on for brekkie. But how do farmers create the best wheat to make our favourite foods? Well, that's a job for the Australian Grain Technologies team.
Hi, I'm James, and right now we're developing new techniques to get the information we need to get this delicious ingredient growing right.
Understanding how wheat varieties are performing can take a really long time. It usually involves people having to collect the data themselves by taking samples, measuring the plants, and making notes on what they can see.
But this is where my work comes in. I'm using existing technologies including digital cameras, LiDAR, and a tractor to gather this data faster.
This process begins with these control boxes permanently fitted to a boom which can be attached to a tractor. 4 digital cameras and 2 LiDAR units are then attached to the boom and their cables are plugged in. This connects the tech to 2 laptop computers and a GPS unit in the cab.
As the tractor moves along, the GPS unit is programmed to guide the tractor's steering.
It sends the tractor's coordinates to the computers, and the computers check this list of coordinates against the coordinates of the plots within the trial. When the computers detect that the sensors are over a plot, the cameras are triggered to take a digital picture.
The LiDAR units are also triggered to collect a scan of each plot.
The LiDAR does this by emitting a laser that scans the ground below. It calculates how long it takes the laser emission to bounce back, which determines the distance between the plants and the unit.
Once we've covered all the plots we want to analyse, we can process the images and LiDAR on the computer.
We use specialist software to analyse the digital images based on the colour of the pixels. These different colours allow us to separate the plants from the soil in the image, or separate different parts of the plant.
This means we can see how well the crop is establishing and growing, and we can measure its senescing, which is how quickly it is drying off and dying.
The LiDAR data can also be processed using code. This allows us to stitch the individual laser points together to form a 3D map of the plots. We can then use these maps to measure the height of the canopy and to estimate how much canopy biomass or total weight there is without having to destroy parts of the plot.
By understanding more about wheat, breeders can then work on developing the best and tastiest varieties for our Aussie farmers to grow.